Hi, everyone. So today we're going to be talking a lot about project 3 and software engineering and teamwork. And yeah, let's jump right in. Okay. So I'm going to tell you a little bit about this project 3 you're going to kick off soon. This will be the last thing you do in the class pretty much. And it runs through now until the last week of class. So it's not really any other things to do between now and then other than, slowly get warmed up for the final. And so let me tell you about this project. So in this project, Build Your Own World, the idea is that you and a partner are going to put together a software system from scratch. So 2B was your first foray into this, and you did it solo. It was a little scary. Some of you are still doing it. And in that assignment, it's all about like picking the data structures. And so we're going to zoom out one level from there, give even more freedom. Okay. So the last time we talked about the software engineering in the previous software engineering lecture, we talked about complexity. And really what I want you to get at, and one of the things that made 2B hard is the complexity. Suddenly now you had way more choices than ever before, right? So whenever you're doing, say, Hog and 61A, you're doing DEX in our class, there's like a thing, you know exactly what you need to do. Even project 2A, it was like, I'm making time series. Time series does this and this and this and this. Once you have that freedom to explore and to build your own thing, the possible universe of complexity is just so vast. Okay. So how do we define complexity? Before I had this quote up, is anything related to the structure of a software system that makes it hard to understand and modify, right? Suddenly you have all these extra choices. So nothing in 61B other than 2B is really giving you enough chance to build truly complex code. And 2B was just kind of a foray. And even project 3, while it's going to give you a chance, you're not really going to see like the true vastness of complexity, but this is really where you're going to get a chance to get a flavor for if you have to pick your own task and your own classes and your own methods, like how does that feel? Okay. So the project has some scaffolding and there's a specific goal, even though your goals will differ to some degree from each other. You're going to be building a system in 2 phases. And the first phase, you're going to generate worlds. That's the building your own world. And in the second part, you're going to make it possible to interact with that world. Okay. So specifically, we're going to do these 2D tile-based worlds. So we have a little tile engine that'll let you, given a 2D array of TE tile objects, you can render it to the screen without you having to do all the rendering stuff. I did that, a few years ago. And so here is a world in which, think about this as these pound signs. These are walls, and these dots are floors, and then there's some little flowery looking things out there, right? And so this is going to be the avatar of the user, and they can walk around. And so phase 1 is generating this world from a random seed. And then the second phase will be being able to walk around in the world. And the baseline is just generating the world and walking around, but some students have a lot of fun with this and go super extra, and maybe you will be one of them. So the idea is given a random seed, which is a long integer, a 64-bit integer, you'll use that as like the starting point that will feed your random number generator, and that is explained more in the spec. So that if I enter the number 343434 as my seed, then I should always get this world. So this is world number 343434. And how many different worlds are there? Well, as many different integers as there are, okay? And so when you're given a number, you're going to generate a 2D world, and it has to have 2 things, rooms like this and hallways. Now we're not explicitly defining exactly what constitutes rooms and hallways, and that's why your projects are all going to differ to some degree. The specific algorithm that you use to generate your world will result in an aesthetically different universe, the one you build than someone else's. This is, I don't think my code. I think this is a student. Yeah, this is a student solution. So that is a different feeling than the one that I built. There's many, many different ways to approach this. It's vast numbers, okay? And so there's some syntax here to the string that, or to the input the user puts in. Actually, what they're going to do when they start the game is press N for new game. Then they're going to do 343434, and then S to say I finished entering the seed. Okay. Don't worry about this method here, what that means. Okay. So that's what you're going to be building. You're going to have a friend, and it's going to open up a lot of possibilities. So part 1 is going to be all you give it pre-canned strings, but there's no actual interaction with the user. And in part 2, you're going to add this new interact with keyboard mode. So in the first part, you're giving it a string like so. In for new game, 343434S, actually build the world. And then interact with keyboard, it's going to be a live interaction. So your game's going to have basically 2 play modes. One where you play it straight from just an arbitrary string, and another that is interactive with somebody at the keyboard. Okay. And so what that interaction is it gives you the ability to move around the world at a baseline, and even better if you can somehow manipulate the world or be affected by the world. But the baseline just moving, if I press D, 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 you can't really see this super well, but D is going to be the key for moving east. So you go east, 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 east. Okay, so you'll end up here. I know this picture is kind of small, but the idea is you can move through the world. Okay. And you're going to have to be able to handle not just a pre-canned string that's fed to your game, but also you'll also be able to do interactivity. Okay. So I gave the example that the user is, the user is pressing DDD, but we also want to be able to support, again, these pre-canned strings. So this basically, if the person started the game, did in343434s, that part of the string creates the world, and then DDDD advances the state of the world 4 spaces, like, or basically this person's going to move over 4 spaces. Okay, any questions about sort of the big picture goal? I know I haven't fully explained it, and you'll be reading a spec, but anybody have any questions that come to mind right now? Okay. So let me give you some examples of what has happened when people tried to do it. It's called tactical programming in the Oosterhout book that I'm using as the baseline for this in the previous software engineering lecture. So we're going to look at this code and think about what's complex about it. And, there's some common patterns with other code we've picked on in lab and in class, but I want you to stare at this for 30 seconds and figure out what are the things that make it complex, that make it hard to understand and modify. Maybe let's interpret the code real quick. This third line of code here, where we say world player x center y center equals player, and the next one where something gets set equal to floor. Why are we assigning something to floor? Anybody want to wager why that happens? Yeah.
We need to erase the old position.
Right. So where we were, we take a step away. We have to erase the Josh Hug that was here and replace with air. Okay, so this is the new position. That's the old position. All right. Let's make that clear. Okay. Don't know why that happened, but that was cool. Okay. So what are some things that are complex about this code? I'm not saying it's bigger. Too many words. Tell me more.
I look at that and like, let's go with that.
Right.
The goal of programming, like the goal of software engineering is to do as little code as possible. So, I mean,
Whoa, don't like that. Okay. Could benefit from some variables. Right. Right. There's a lot of, I mean, the classic thing we pick on is like, there's a lot of repetition here.
yeah, like we're not girl, like blah, 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 blah. I mean, I'm pretty sure that like makes more sense.
Right. It's hard to read, I guess. It's not very narrative. All right. I'll note, by the way, I don't know that I always agree that it should be as little code as possible, because otherwise you end up with code golf. I don't know if you've seen that, but code golf is a practice of trying to write code in the fewest numbers of characters. So
How about reverse
yeah, leap years. Let's see. I'm trying to find some code golf answers. I wanted to see that answer. 43. So how do I see the solution? This is not what I want. Just show me an answer. I haven't seen it. Okay, whatever. Anyway, it's basically like cramming all your code in one line. Don't do that. Yeah. Cool. Other thoughts? What's complex about it? Yeah. There and then there. Yeah.
For one thing, if you have to change something, then it's just like having just one function. Each option you can like call that.
So there's some sense that the repetition means you're going to have to repeat changes in many places. Back.
I was saying this could all be brought down to one method. It's the same exact line.
Yeah, right. And so it feels like there should be some kind of helper method that's going to figure out like the target position. Like maybe there's a method called like up, right, down, and left, similar to what you saw in project 1A or in project 1 in array deck. There was that suggestion like having a helper function that does the thinking for you. Another way of putting that is like the calculation of the neighbors is very low level and right there for you to see. Hide that gross code, please. Other thoughts? Other things that just make it hard to understand or modify. Yeah. Like, for example, worlds instance variables. That's an interesting one. What's the alternative? Oh, like calling a function, right? Might make more sense to have a move player left method, something like that, that does the variable manipulation. And that's arguable because it's like, it's simple enough that maybe it's okay that this class should be changing it. Maybe not. It's one of those things you just feel out and there's no right answer. Other things that feel kind of hard coded or repetitive. Yeah.
Seems like maybe you could, instead of using 3 ifs, you could use like a switch statement.
Instead of 3 ifs, use a switch. Yeah, might make things seem nicer. There's something I don't like about tileset.wall. Any idea what I don't like about that? So what is this doing? Why is it checking to see if something equals wall? What do you think? Just off the top of your head. Yeah. Or go ahead. So you can't move into a wall. So why do you think I might not like this dot equals tileset wall? Yeah. Oh, like change it to some other, what do you mean change the wall tile? How would you change it? Right, yeah, so maybe you want to support not moving into lava, you know, I don't know. Door, yeah, wall, potato sack, whatever, right? Cool, okay, so all reasonable changes. Okay, so what are some things we might do to simplify it? So we've already got some suggestions that came out, like for example, helper method that moves player left, right, up or down, switch statement, code that calculates the up, left, right, or down position. Other thoughts? Anybody have anything else that jumps out at you? Yeah. Mhm. Right. Helper method to see if yeah, a blocking tile is in the way or something. Yeah. Like a valid move. Like that. Other thoughts about how you might make it simpler? And this may seem silly, but this is real code that someone wrote in this class, and you may find yourself writing this code, and I'll come back to why this kind of code comes to exist. Point it out for you now. So when you're writing code, once you start smelling your code, let's start smelling like this, you know, to take a break, clean things up. Yeah.
Maybe this is like specific, but all those steps plus equals 1.
Move it out. What do you mean?
It's in every if statement.
Oh, steps plus equals 1. Yeah. Right. Steps plus equals 1 is repetitive. Don't do that. Yeah, it's like literally in the code in multiple places. That's a very dangerous thing. That's a bad code smell, as they say. All right. So complexity. Well, there are, Ostro goes on and he kind of breaks down complexity and says that there's 2 different real flavors of it. One of them is dependencies, which is when you can't read a piece of code on its own. You can't read, understand, and modify it independently. And then there's obscurity, which is when there's important information that's not obvious. So both of those happen in the code we just saw, partially because this dependencies, I need to understand a little bit about the structure of this 2D world array, arguably. But if you had helper methods that are called something like move left or left of or whatever, then you don't need to be thinking about those variables. So there's no, like, there's always going to be dependency, but you want to minimize the degree of dependency that makes it hard to understand code. And And the other is obscurity. It's not exactly totally obvious. I mean, it's getting there, but it's not totally obvious that YY center +1 is in the up direction, or maybe it's in the down direction. I actually don't even know. And so, that could be addressed with a comment, for example, or it could be addressed by having helper methods that make it more narrative. Okay? So both of those things happen in this code. And the basic idea is that when you build code, ideally, when you're building really good systems that are supposed to last, or when you're just trying to get practice with keeping complexity down, you need to remain really vigilant to keep from dependencies and obscurities from infesting your code. So one of the things that makes, I'll give you an example. You may remember in the project 2B spec, I said, please don't make a big global variable that's static, that's an n-gram map. So I'm going to repeat that warning for this project. Do not do static variables that everybody can access, because then it just gets very complicated to keep in your head how everything's supposed to work. Okay. So let's visit those complexities explicitly on the slide here. So this strategy of basically, oops, just doing it again. Okay, I got to figure out how not to do that. So this strategy of that you often have in 61B, where you're like, I just need to get something working. I'm going to just, throw in my +1s and -1s and so forth. That's known as tactical programming. And while you can maybe kind of get by with it in ArrayDAC and linked list DAC, you might have already seen in 2B, it's very hard to make this actually work. And in project 3, it's going to be just even more difficult, because you're going to end up with code like this. And you may be able to, pass the auto grader and get a reasonably working project, but it's not going to feel good to work on your code, because it's going to be a mess to always interact with. The point is here, someone who's being tactical. They're just trying to get the next thing working without thinking about the overarching architecture and the creeping complexities and dependencies. So when we say what's complex about this code, these top two, I said a couple of these things out loud, but this complex manual computation of west, east, north, and south, that is a kind of obscurity, right? It's like, it's not obvious that this is up versus down. You can kind of tell, but it's not totally obvious. And then there's actually just a lot of variables that need to get manipulated just so. For example, steps has to get incremented in all of these places. That's a little bit obscure. We also have like player XX center needs to be -=1. And there's just this sense that there's just a lot of things that are not obvious, that if I just sat you down with this code and you didn't know the code base well, if you didn't have this right in front of you, you might not recognize that you need to change both players X center and then also the world variable, right? So it's just a little weird. And the way you can make that better is by setting up nice encapsulated hard abstraction barriers rather than lots of low-level nitpicky details. And then of course we have this repetitive code. So there's a dependency, which is that I can't modify this code independently. There's like this repetition and it needs to always be there. And this is bad. Okay. All right. Now, I mean, I maybe sound a little repetitive because I talk about this a lot in lecture, but this sort of thing is really important because code often starts out beautiful. I mean, basically all code starts out beautiful. It's just a blank file. But it's over time that as you like add just extra hacks, every time you want to get just one more thing working, you always have this debate between taking a breath, stepping back, and then re-architecting to make it work, or doing the couple lines of code that will maybe get you towards the goal. And it's a delicate dance, right? I mean, it's hard to say when it's the right thing or the wrong thing to go one way versus the other. I actually met with one of my former head TAs yesterday, who he works at a company that I helped start kind of over the summer. And it was funny because he was saying, when I first started, I was like, the CTO was like, hey, you're like moving awfully slow. And he really just couldn't get over the idea that he needed to be doing really good strategic programming. So my CTO had to say, hey, it's okay to write shitty code, as he put it sometimes. We just, we need to be tactical when we're experimenting. So it's not like you always want to be absolutely strategic in all cases, though Osterhout would argue that you should. But it's a delicate balance between hacking something to get it working and making it beautiful and last forever. Okay. But I'd say that this, even in 61B, I'd say if you're writing code that looks like this, I think that you're missing out on part of the educational experience of the class. Okay. Because learning to keep complexity under control is super important. Any questions about that before I do my next mini spiel? All right. So in part 2, let's talk another example of complexity. So in part one, it's all you give your code strings and it outputs worlds. In part two, you need to interact with the keyboard. You need to give the person who is using the game the ability to move their avatar, a little @ sign, around the world. So you need to be able to handle these movements with the input string method and the keyboard method. Okay. Now, handling these two sources of input in a way that is not complicated is hard, right? We have here if move equals A. So there is some commonality. We don't know if this A came because someone pressed A or because an input string came in. But one layer out in the code, once you zoom out a little, it's like, where did the A come from? And it's very easy to do this in a messy way. And the very first time I ran this project, I didn't give anybody any kind of tips about this. And it was like a bit of a nightmare with this really massive reduplication of code. So I give away some ideas both in lecture and in the project. So let's talk it through a little bit. Okay. So in the solution below, what interact with keyboard does is it calls move keyboard. So let's look at this thing. So here we have this interact with keyboard function. That's one that we require. That's in the API for the assignment that you have to do. They've written a custom move keyboard that basically says, give me one character of input. And if that move equals W, then do all this stuff. And then there's the other mode for the game to be played, which is to interact with input string. In that case, that function calls move character. And what does move character do? Well, in this case, you give it both the world and the character that got pushed. For reasons that I don't need to go into, it's converted into a string. And then you end up with, this other code down here, which you'll notice is quite similar, right? So in fact, what this person did is, and this was pretty common in spring 18, I think we first ran this project, is people basically have two games. One that was written hard-coded to use the keyboard and one that was hard-coded to use the input string. But for obvious reasons, we're not going to go through that same exercise, like what's good or not good about this. It's just fully repeated. So how could we do better? What's some ideas? I'll give you guys maybe a minute to think about this before I solicit any examples. How do you do better than this? All right, thoughts? Oh, okay. So I did that thing. So someone did stop by office hours and had this MacBook, and I liked using it. I was like, I'm gonna try one of those. So I'm experimenting to see if I want to use a MacBook. We're learning what's good and not good about it. Boop sound. Yeah, go ahead.
The string move in the move char, like pass that as a parameter to the move char method.
Right. So we can have move. Let's see. Move. Say again. Sorry.
We can pass the character from object.
Right. So move keyboard can call move car with the keyboard it collects. I think that's a reasonable plan. Yeah. Other thoughts? Yeah. Right. Helper method that both call. That's the other approach, I guess. Like in a way, yeah. So it would be a helper method that both call. So move keyboard and move car use some common function. Yeah. I don't know that one's better than the other necessarily. They're very similar. I have another approach that's kind of fun. So the way I did it, by the way, and I think I mentioned this in the spec, pretty sure, is you could also use inheritance in an interesting way, where you could actually add another parameter basically to your function called input device. And the input device has a next character method. And then whatever method you're calling, you're going to pass it an input device. And so in that case, that input device could be from the keyboard or it could be from the string. And so the reason I like this approach is it opens up even more input device possibilities like network play and whatever else. And so that's the approach I'm going to recommend, although it's a little bit of overkill for this project. So I'm just putting it out there. Okay. But I think that this idea of like one function calls the other is a very good solution, perfectly reasonable, though I encourage you to experiment maybe with this idea if you want. All right. So fundamentally, what I want to get to, last thing I want to say about tactical versus strategic programming, and since I didn't formally say what I mean there, tactical is only thinking about getting this done. Strategic programming is thinking about the big picture. So this is a dog attempting some tactical programming, and I want you to not be this dog. Okay, here we go. I don't think we have sound, but.
Come on, let's go. Come on,
Right,
come on.
working on it. Okay, let's see. Busted again. Anyway, so it's kind of the vibe I get. You got to work smarter, not just harder. He's really trying. Let's skip forward a little. You go, oh yeah. Oh, okay. Oh, sad. Oh, you got it, my dude. Good. Anyway, all right.
That's a good boy.
Anyway, all right. So don't be that dog. It's very tempting when you're a novice programmer to really just stick with the thing that's kind of working for now, but it doesn't always work. Okay. No. All right. I think I know what's going on. What happens is that the cursor gets stuck on that transcript that you can't see right now. And then there it goes, poop. Okay. So I've mentioned many times these ideas of encapsulation and so forth. So I'm going to talk one more time about them in this class at this philosophical level about modular design. And so one really powerful technique for managing complexity that I really want you to keep in mind in project 3 is to design your system so that you're only thinking about some of the complexity at any given time. So for example, if I have get neighbor west, that'll tell me the position of the west point that we're looking at. So we have a position in space, we ask for its west. Saves you some time. Or if we have helper classes like input device, then you're hiding complexity. It's a really important concept, okay? Now in an ideal world, you would actually just go totally crazy with this and you would just break everything down into modules where every module is totally independent, they're easy to test, and you'd just be like gluing things together. And here module is just some informal term about a nicely encapsulated piece of code, whether that's a package or a class or something else. But of course, it's not possible for modules to be independent because they have to be able to call each other. Okay? So we need to know what are the methods in your piece of code. And when you're on a team project, that's something you're gonna have to agree on. What are the methods? Okay. So in modular design, though, the goal is to minimize these dependencies between the modules, things you need to know about the other module in order to use it. Okay. And so we've seen that again many times in this class where, say, I have a disjoint sets interface. There's many different implementations. But to use any of these, there's a common language, okay? And so what's nice about this is that each of these implementations, they have a nice, clean API. One of the things I love about Java, okay? Now, as Osterhout puts it, the best modules are those whose interface, and this could be a formal Java interface, or it could just be like an informal agreement about what a class should do. But we want a module's interface is simpler than their implementation. Well, why is that? Well, one is a simple interface means you don't really need to worry about that complexity of that module spreading. So for example, if I have an input device and the only thing it do is get next, that's all someone can do with it. There's no chance they're going to do something wrong with it. If a module's interface is simple, then we can change the implementation without affecting the interface. So you'll notice that the disjoint sets interface, it doesn't expose details like, for example, let's say like parent, like what's the parent of the item in the disjoint sets tree? Because, well, then that's a very specific detail and maybe you don't actually implement it as a tree of some kind. Or another example is suppose that list had an array size method, then yeah, you'd be stuck using an array, right? This wouldn't be the right thing to do. Okay. Now, Java interfaces, I should note, have both a formal and an informal part. And this is a very subtle point about programming in general. When someone gives you a specification of how their code works, there's the part they tell you, and then there's the part that they don't. So the formal part is this list of method signatures, and the compiler enforces that, and it is law. The code is law part of everything. And then informal are all the rules for using it that are not enforced by the compiler in the case of Java. Okay. So for example, common rookie mistake in 61B programmer life, if you write an iterator that assumes that has next is called before next, then you're breaking the rules of what the the informal agreement we've all made about iterators, right? This isn't something that the compiler can check, but it may be that you write an iterator where, let's take the whiz pause, right? You remember whiz pause? Imagine that whiz pause in the constructor was not initialized, but the first time you call hasNext, it gets initialized. That would be syntactically correct and it would work most cases, but it'd be breaking the informal rules for how iterators are supposed to work. Another example, let's say you have an array set method or something, and the add method throws an exception on null inputs. That's an informal part of the interface. It's something that someone has to learn to use your class. It's in the rules they have to keep in their head. Or if I want to, for example, add something to an array list, even the runtime is part of the informal rules for using the interface. You saw that in 2B. Some of you, out of curiosity, did anybody here get a timing error because you were trying to use you were trying to do retain all or index of or contains in an array list? Anybody have that one? Yeah, a few, right? And part of that is that there's an informal rule that array lists are slow on those operations. Okay. All right. By the way, add an array list is very fast. That's just something we all agree should happen, at least if you're, I don't think add lets you add in the middle. If it lets you add in the middle, though, it'll be slow. And so the informal rules, they can only be specified in comments, in documentation, in English, or maybe it's just a thing that an institution gets to know. You work somewhere, everybody just gets to know the quirks of the library, okay? So what I want you to do, this is gonna be one of my last vague programming admonitions for Project 3, is really be aware of these informal rules of the modules as you build Project 3. And one of the best things you could do for yourself is not having any static variables unless they're like final and that they can never change. All right. It's another cool idea I like out of Oosterhout, which is that modules should be deep. So they're simple interfaces, but powerful functionality. We do that a lot. Like that's kind of the 61B story. Like a set is a very, it's a deep module, has powerful functionality, but simple interfaces. So red-black binary search trees, for example, is very deep, okay? So I can add, contain, and delete, and there's nothing informal you need to know. You don't need to know which nodes are red or black. That's all under the hood, okay? And the functionality is powerful in the sense that the operations are efficient. And the other thing is that the tree balance, it happens under the hood with these sophisticated and subtle rules that are hard to teach. And you'll probably forget them in like 3 weeks, right? Like once the final's over, unless you get engaged in CS education or for some reason build a red-black tree, you will absolutely forget how red-black trees work. It's just too subtle. And that's fine. And I hope you enjoyed the journey while we learned it. But the point is like, they're tricky, but we hide them under the surface. Okay? And so the most important way to keep your modules deep is to practice information hiding. So that is, make your variables private. You know, don't let anybody see what's inside the module as much as you can. You want to basically embed all the intelligence, all the cleverness in the module itself, but you don't want to be able to see inside the modules, okay? So that'll keep your interfaces simple, and it'll also make it easy to modify your system. If I decide, oh wait, I messed something up in the like get west neighbor function, you can go fix that without thinking about it in the context of actually playing the game, okay? Now, the opposite of hiding information is to leak information. That happens when the decision is reflected in many different modules. So if you change anything, you have to change all of them together. So the code from before, it had these two move methods that process input in very similar ways. So information lives in two places. It's embodied in two places. It has leaked. Don't want that. Okay. And so Oosterhout, he feels like when it comes to tactical versus strategic programming, information leakage is like, that's the warning that says you're doing something wrong. This is a major red flag. And so one of the most important things in his view is to be very sensitive to information leakage and to realize anytime you're making a decision that now everybody needs to know about, like at any level of the software project, you're causing yourself a lot of pain. Okay. Wow. And so one of the biggest causes of this is what's called temporal decomposition, where the structure of your system is going to reflect the order of events in which events occur, or the order in which events occur. So for example, students often do the following in Build Your Own World. Okay. So the game is started with an input string. So we call interact with input string. We parse the string and find the seed by extracting in .. s, where this is the seed in here. So you have to do some parsing of the string. Then you generate the world. Then you process each character using move world character. And then let's say someone starts the game with no input string. They're doing it with a keyboard. Well, in that case, they display a menu and collect the seed. That's like the number that we're using to generate the world. Then we generate the world and so forth. And what you'll find is that even though in your heart you know you're supposed to do it, people will write code that doesn't actually share anything, or maybe it shares the parsing function, but nothing else between these two. You really want these two tasks to be as similar as possible. But because of the way that you wrote the code and the way that you structured your thinking about the project, you did project phase 1 here, and then you did phase 2 here, because the temporal decomposition of when you worked on the project and the temporal decomposition of when these things happen, you don't really recognize that they should be sharing. So just be aware. Okay. I think I've said pretty much as I can say about software engineering at a high level. So project 3 will get a chance to hopefully digest some of these messages, and hope that me kind of ranting about philosophy has been interesting. Certainly less stuff to memorize for the final. And so let me give you just a last few set of suggestions, and then I'll talk about teamwork, which is actually a surprisingly fun topic. Okay, so when you're going to build your own world, I really want you to build classes that provide the functionality that you need throughout your code. So a class should be like a general purpose helper, like a class that helps parse random seeds or whatever. You want deep modules. So they're classes that have simple interfaces that do complicated things. Do not rely on temporal decomposition, where you're just decomposing based on when things occur, right? Even though these two tasks are not part of the same workflow, this is someone playing the game from a string, and this is someone playing with a keyboard, they can still share code. And it's okay to have some degree of that. I mean, often breaking things down, like A needs to happen, then B needs to happen, then C needs to happen. It's fine if you have module to handle those cases, but just be aware where the information leakage occurs. Okay. Be strategic rather than tactical insofar as is possible. Like, don't just hack your code until it just barely works. And then hide information from yourself when needed. Use the private keyword as much as feels sensible. And every time you decide something is public, like, have a good reason for it. Okay. All right. Let's talk about teamwork. Different total pivot. And this is more kind of like social sciencey, but I think it'll be fun. All right. So I got some more war stories here too, which is fun. So project 3 is a team project. We're doing teams of 2, and there's 2 main reasons. 1, we want you to get some practice working on a team. And 2, it's a creative project. Like, this isn't, do you really know how to take your code and debug it and get the autograder to obey its, get your code to obey the autograder specification. This is, I want you to work together and really come up with something cool. Okay. There's another reason, of course, which is that it reduces the programming workload per person, but that's actually not the main goal. And this project could be done solo. It's like maybe marginally, it's somewhat smaller than project 2 overall, I'd say, the amount of code you'll write. Okay. And so this project, I've always had a software engineering project in 61B. 2015, it was Gitlet. In 2016, it was Editor, which is a text editor. 2017 was a partner project in databases. And then I've done Build Your Own World ever since. And actually 2021, we had 2 of them. We also had Gitlet, but I didn't like that. It was bad. And so interesting experience I had is that semester when we first had partners in 61B in 2017, I thought, well, this could be easy, right? Like, instead of working alone, you have somebody else. And we had very little scaffolding about how partnerships should work. But actually 8% of people were significantly unhappy with their partnership. Like, I think maybe things were worse for them than they would have been otherwise. Now, of course, in the real world, like, I had this experience at the startup I was at this summer, where when I'm working on a problem alone, I feel way less smart than when I'm on a group of people, with a group of people working on the project. And some tasks are just simply too large to be handled by a single person. I mean, obviously, and some you just move way faster. There's this interesting, like, really multiplicative effect when you get a group of people working on something. So a team can succeed where just one person will fail. And I suspect if I were to take you and put you in groups of 4 to work on the final or whatever, like, even if the exam groups were fairly random, I think probably, you guys would be hitting exam scores. Like, the median, I'm gonna make up a number. I'm not gonna do the experiment this fall, but I don't know, it might be a 90, maybe 85, something like that. It's just, yeah, you could do better as a group. Now, what's interesting about this is, like, people are often thinking about, especially at Berkeley, where you come in and you're, maybe some of you have been training since birth to go to college, and some of you came in like learning calculus whenever you got here. And so there's a sense of what you're personally capable of. So I'm going to give you a little contrast between individual intelligence and team intelligence. So in 1904, Spearman, famous educational psychologist, he very famously demonstrated the existence of an intelligence factor in humans. And he showed that there is some correlation between your ability to do a bunch of different cognitive tasks, and said there's some latent factor that by adulthood you've developed, whatever its nature is. Okay? So it's described in Woolley, people who do well on one mental task tend to do well on others, despite large variations in the test contents and methods of administration. So if I have you trying some totally new thing that you've never seen, it's just, there's going to be a lot of overlap. And so this mysterious factor is called intelligence. Spearman and other follow-up works says it can be measured pretty quickly in less than an hour or so, and it predicts a bunch of life outcomes. So like grades in school, success in occupations, life expectancy, and so forth. And there's nothing in Spearman's work that says that this factor is genetic. It's just an observed property that people tend to have some level of fluid intelligence to solve problems. In principle, that's what we're trying to develop. Okay. Now, group intelligence is super interesting. So this pretty famous paper in which Woolley and a bunch of others investigated the success of teams of humans on various tasks. And they found that performance on a wide variety of tasks is correlated, that similar to Spearman's work in early 1900s, groups that do well on any specific task tend to do well on others. And there's a pretty wide variety of tasks that you can check the paper out if you're curious. But this suggests that groups have some sort of like group intelligence that's analogous to individual intelligence. And what's interesting is that studying the individual members, building on Spearman's work, they found that the collective intelligence of a group, if we think of it as this group ability to solve problems, it's actually surprisingly not significantly correlated with the average or the max intelligence of a group. So you might assume, well, you've got someone who's going to carry the whole project. But at least in this experimental setting, that wasn't the case. Instead, I found that collective intelligence was correlated primarily with three things. I'm not an educational psychology researcher, but one of them was very fascinating to me. It's the average social sensitivity of group members as measured using the reading the mind and the eyes test. What is that? So basically it's, is this person playful, comforting, irritated, or bored? Is this person terrified, arrogant, annoyed, upset, etc.? So that ability to like sense what someone else is feeling, like what's in their brain, was pretty important for this. Okay. Another was how equally distributed the group did in conversational turn taking. So if someone's really dominating conversation, the group is not benefiting from this group intelligence factor. And then the third, as they note, there's a percentage of females in the group. Hey, ladies. Anyway, but the paper suggests this is due to a correlation with greater social sensitivity up here. But yeah, so they've been, using their educational psychology research techniques. This was their sense of how this went. Right. Okay. I'm not, by the way, trying to indicate that females are superior to males, nor and at the time they did the study, females is the characterization they use. So there you go. Okay. So presumably, learning habits that lead to greater group intelligence is possible. It's not literally that test. It's not like if you study the mind and the eyes test that your group is going to do super awesome just by virtue of the fact that you guys can read the eyes, but it's a demonstration of something. And so what we're hoping is that part of your college experience should be partner work, even though what I've been trying to do is not like a ton of partner work at 61B. I'm hoping that we can build more of this group intelligence because I think it could be really helpful to you in the future. So I want you to really recognize that like teamwork is about the relationship. Like what makes a partnership fun is actually communicating with the person, getting to know them, griping about things together, whatever it may be. So it's of course really important to treat each other respectfully. Be really open and honest as much as you can with each other and like set clear expectations. Expectations are everything, right? When I think about teaching, when I'm successful, it's because your expectations match what happens. And that's not the case, like office hours queues are 2 hours long or whatever, that's not great. And so if those expectations don't get met, like really talk to each other and say like, hey, what's going on? Why are you behind? Or, what's up? See how it goes. By the way, quick anecdote. The reason that 61B is largely solo is partially a result of a one-off conversation I had when I was interviewing for this job with the person who's teaching 61C, who was concerned that the 61B students at that time, like 61B was very partner project heavy, and people would get into 61C and not really know how to do everything themselves because they hadn't built like a certain set of basic programming skills. So as an experiment, I pared back the partner projects quite a lot. I'm generally happy with it, even though I know it's stressful, especially when you're kind of alone and waiting at office hours. And if there's one thing I could fix in the universe, it would be like never having anybody have the sense that like, I'm just stuck and there's no way to proceed. So ongoing project. Right. A little more philosophy. So in a really important part of teamwork, and this is from that teaming by design page I linked at the beginning. So a group's ability to actually step back and think about what they're doing, like their objectives and how they're thinking about things and the processes they're using, that's extremely important. That's reflexivity. Okay? So as the team by design people put it, you really, I mean, it's only two people, so kind of narrow, but you want to have a collaborative environment in which really giving and receiving feedback is an important part of the whole process. Okay, so it's okay, and actually we expect it, that you and your partner are not going to be necessarily evenly matched. That's okay. You know, you're learning from each other and you're going to have a group ability that's greater than the sum of your parts. Okay. So there's a link here if you're curious that talks about best practices for team feedback. If you really want to get formal with it, but you don't have to. Now, I want to note one thing that's really hard, and I see this all the time, like at my side gig, where feedback is tough, right? Like most of us have gotten feedback from someone that feels judgmental or like in bad faith. So sometimes we're afraid to give constructive negative feedback. Certainly I am, for fear that someone's going to think I'm attacking them, right? And so we're also conditioned when someone gives us negative feedback, we're like our default position is like, or there's many people, mine is a little bit, that it's ill-intentioned in some cases. So I'm kind of curious, like what's some examples you've had academically or otherwise where feedback you've gotten, like negative feedback, felt tough? Yeah.
Like resume critique.
Oh, resume critique. So yeah, but how'd it go?
I mean, I knew that like they might get by it, but just even still, like I still kind of felt bad that like maybe they didn't really value like whatever projects or past experiences I had.
Right.
Even though like
Right. They valued what I was putting down on there. Right. Other thoughts? Nobody else? Want some more negative feedback? That's tough. Nobody? Well, thank you. All right. Okay. Feedback also, of course, because they make a waste of time. You're on a project, you just want to get it done. So you might find it pointless. You're gonna have to rate each other twice during the project. In the real world, it's gonna happen a lot. You know, your team has limited time to figure out what to do. And so it'll feel annoying that you have to stop and reflect on how you're working together, right? But it turns out to be valuable. You're like paying a little bit now to get better processes later. And then also I'll note that feedback is really difficult to produce, right? So you might be able to build incredible technical skills at Berkeley, but learning how to provide useful feedback is super hard without making someone else feel like, you know, you're demeaning them or it's ill-intentioned. And like, this is all soft skill stuff, but it's super, super important, right? Like companies collapse for this reason because people don't get along or someone doesn't know how to explain to someone else what you're working on isn't quite the right thing, right? So without confidence in the ability to provide feedback, then what's going to happen is you're going to wait, and it's just going to be hard to, you're never going to actually get to the point of providing feedback until it's the very last minute. So what I'll note is that if you feel like your partnership could be better, talk about it without waiting until you have to review it, right? So try and be buddies and talk. Okay. And so the last thing I'm going to do is we're going to have you reflect on your team's success twice. Once to talk about whether or not the partnership has worked well for you, for your partner, and you're going to estimate how much you think the balance of work is. And we're not expecting that it's exactly even, but if you say 50-50, then you contributed about equally. And we're not saying lines of code. We mean just like a sense of contribution in a given sense, because it may be that one of you is in, you know, an A+ student and one of you is B- student. And that's fine. But we'd really like you guys to collaborate and have a deep relationship that feels productive. Okay? And if applicable, we're going to ask you to give great moments from your partnership and what's something you could do better, what's something your partner could do better. So I'm just putting it out there so you have this in mind, but we're not going to be penalizing people who contributed less unless things go really off the rails. Okay. So that said, I hope you enjoyed my little mini rant on software engineering and teams. And I will see you guys Monday and we'll do some more quick start. All right. And let me know what you think of these like philosophical Friday lectures that we do at the end. I'm gonna stop the recording.